According to the National Electrical Code, specifically Section 547.1a, certain environments require dust-proof fittings and boxes. This is particularly relevant in agricultural buildings such as horse stalls. The reason for this requirement is to prevent the accumulation of dust and other particulate matter inside electrical enclosures, which could potentially lead to overheating, short circuits, and even fires. A Type 4X box, such as the one shown, is designed and manufactured to meet stringent standards for protection against dust, water, and corrosion. The Type 4X designation indicates that the enclosure is suitable for both indoor and outdoor use and provides a high level of protection against environmental hazards. This makes it an appropriate choice for use in horse stalls where dust, moisture, and other contaminants are commonly present. When selecting electrical components for use in agricultural buildings, it is essential to verify that they are specifically listed or labeled for the intended application. This ensures that the products have been tested and certified to meet the relevant safety standards and performance requirements. In the context of wiring methods, underground feeder cable, commonly referred to as UF cable, is frequently used in agricultural applications. UF cable is designed for direct burial in the ground, making it suitable for underground wiring runs between buildings or structures. It is also resistant to moisture, abrasion, and sunlight, which are important considerations in outdoor environments. However, it is crucial to follow all applicable code requirements and manufacturer's instructions when installing UF cable. This includes ensuring proper burial depth, using appropriate connectors and fittings, and protecting the cable from physical damage. When installing outlets and lighting fixtures in horse stalls, it is important to select products that are specifically designed for agricultural use. These products typically feature sealed enclosures, corrosion-resistant materials, and other features that enhance their durability and performance in harsh environments. It is also essential to ensure that all electrical work is performed by a qualified and licensed electrician who is familiar with the specific requirements for agricultural buildings. The National Electrical Code provides detailed guidelines for electrical installations in agricultural buildings, covering topics such as wiring methods, grounding, bonding, and overcurrent protection. Adhering to these guidelines is essential for ensuring the safety and reliability of the electrical system. One should reference the specific requirements outlined in Article 547 of the NEC, which addresses electrical wiring in agricultural buildings. This article provides detailed information on the types of wiring methods, equipment, and installation practices that are permitted in various agricultural environments, including horse stalls. It is also important to consult with local building codes and regulations, as these may impose additional requirements or restrictions on electrical installations in agricultural buildings. These codes and regulations are typically enforced by local authorities, such as building inspectors or electrical inspectors, who may conduct inspections to ensure compliance. Some of the specific requirements that may be addressed in local codes and regulations include the height of outlets and switches, the type of grounding electrodes, and the use of ground fault circuit interrupters, or GFCIs. Ground fault circuit interrupters are safety devices that are designed to protect people from electrical shock. They work by monitoring the flow of current in a circuit and quickly interrupting the power if a ground fault is detected. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. GFCIs are typically required in wet or damp locations such as bathrooms, kitchens, and outdoor areas. They are also commonly used in agricultural buildings, where the risk of electrical shock is higher due to the presence of moisture and other conductive materials. When selecting electrical equipment for use in horse stalls, it is important to consider the potential for exposure to corrosive substances such as manure, urine, and cleaning chemicals. These substances can damage electrical components and lead to premature failure. To mitigate this risk, it is recommended to use corrosion-resistant materials such as stainless steel or PVC for enclosures, fittings, and wiring. It is also important to regularly inspect and maintain electrical equipment to ensure that it is in good working order. This includes checking for signs of corrosion, damage, or wear and tear. Any damaged or worn component should be replaced promptly to prevent electrical hazards. In addition to dust-proof enclosures and corrosion-resistant materials, it is also important to ensure that all electrical connections are properly made and protected. Loose or corroded connections can create resistance, which can lead to overheating and potentially cause a fire. All electrical connections should be made using approved connectors and fittings, and they should be properly tightened to ensure a secure connection. It is also important to protect electrical connections from moisture and other contaminants. This can be accomplished by using weatherproof connectors and fittings, or by sealing the connections with a suitable sealant. Furthermore, it is vital to ensure that all electrical circuits are properly grounded and bonded. Grounding and bonding are essential for providing a safe path for fault current to flow back to the source, which helps to prevent electrical shock and fire hazards. Grounding refers to connecting the electrical system to the earth, typically through a grounding electrode, such as a ground rod or a metal water pipe. Bonding refers to connecting all metal parts of the electrical system together, such as enclosures, conduits, and equipment grounding conductors. This creates a low impedance path for fault current to flow, which helps to trip the circuit breaker or fuse and energize the circuit in the event of a ground fault. The size of the grounding and bonding conductor should be selected in accordance with the requirements of the National Electrical Code. It is also important to ensure that all grounding and bonding connections are properly made and protected from corrosion. Regular inspections and maintenance of the electrical system are essential for ensuring its continued safety and reliability. These inspections should be performed by a qualified and licensed electrician who is familiar with the specific requirements for agricultural buildings. During an inspection, the electrician will check for any signs of damage, wear and tear, or corrosion. They will also test the operation of GFCIs and other safety devices to ensure that they are functioning properly. Any deficiencies or problems that are identified during the inspection should be corrected promptly to prevent electrical hazards. In addition to regular inspections, it is also important to perform routine maintenance on the electrical system. This may include cleaning electrical enclosures, tightening connections, and replacing worn or damaged components. It is also important to keep the area around electrical equipment clear of debris and other obstructions. This will help to prevent overheating and ensure that the equipment can be accessed easily for maintenance and repairs. When performing any electrical work, it is essential to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as safety glasses, gloves, and insulated shoes. It is also important to energize the circuit before working on any electrical equipment. This can be accomplished by turning off the circuit breaker or fuse that supplies power to the circuit. Before de-energizing a circuit, it is important to test the circuit to ensure that it is actually de-energized. This can be accomplished by using a voltage tester to check for the presence of voltage in the circuit conductors. If voltage is present, it means that the circuit is still energized and should not be worked on. Once the circuit has been de-energized and tested, it is safe to begin working on the electrical equipment. However, it is still important to exercise caution and follow all applicable safety procedures. When connecting or disconnecting wires, it is important to use the proper tools and techniques. Wires should be stripped carefully to avoid damaging the conductor, and connections should be made using approved connectors and fittings. All connections should be tightened securely to ensure a good electrical connection. After completing the electrical work, it is important to inspect the work to ensure that it has been performed correctly. This includes checking all connections to ensure that they are tight and secure, and verifying that all grounding and bonding connections are properly made. It is also important to test the circuit to ensure that it is functioning properly. This can be accomplished by using a multimeter to check for proper voltage and current levels. If any problems are detected, they should be corrected before energizing the circuit. Finally, it is important to keep accurate records of all electrical work that has been performed. This includes documenting the date of the work, the type of work that was performed, and any materials that were used. These records can be helpful for future maintenance and repairs, and they can also be used to demonstrate compliance with applicable codes and regulations. In summary, electrical safety is a critical concern in agricultural buildings, particularly in horse stalls where dust, moisture, and corrosive substances are commonly present. By following the guidelines outlined in the National Electrical Code and local building codes, and by taking appropriate safety precautions, it is possible to ensure the safety and reliability of the electrical system. This includes using dust-proof enclosures, corrosion-resistant materials, and proper grounding and bonding techniques. Regular inspections and maintenance are also essential for preventing electrical hazards and ensuring the long-term performance of the electrical system. The Type 4 Xbox is suitable because it is specifically designed to protect against environmental factors common in such settings. Remember to always consult with qualified professionals for electrical installations.